Good day, March 6th, 2024, from a desk of Ross Finlayson here from Seattle, Washington, is another episode and installment of Moment and Motion. Geometry is motion. Today, about metaphysics and logic, is continuing kind of the course of the consideration of logic and the relevance of logic to mathematics, and then that it sort of forms this sequence of logic and mathematics after metaphysics to physics, then for science and probability, that according to mathematics is numbers and laws of the numbers and laws of large numbers, the various laws of the various models of infinity in the numbers, that sort of results in entire continuum mechanics. And it's the continuum mechanics that result describing the continuum of this milieu, which objectively exists, and that each then has their own kind of object sense, word sense, number sense, time sense, a sense of the continuum and the relation of things in it. So that's kind of grandiose, one might aver, that there is a continuum of things, and then it has its infinite fractal detail and all such manners of that which comprise its panoply of relation and summary and digest and discourse and the constancy and consistency of diversity and variety that results in all sorts of manners of the contemplation of things, turning them over in the mind, the ponderance of things, how they are and what they are, why they are, and answering the question words vis-a-vis the usual notion of declarations and definition, which results are didactic approaches to making theories of things, that it also is a great complement of answering the question words in the context of where they are with regards to the uniqueness of things and the distinctness of things, with regards to the existence of things, and then that is so for each, for any, for every, for all, for this sort of the universal quantifier of these things. And then as with regards to here in the notions of the tendencies and propensities of oscillation and restitution and dissipation and attenuation, which makes for the constitutive and reconstitutive of things in terms of their state and how they change. And here for moments is of the state of things and the state of a change of things, and motion, this constancy of the only constant is change, that it reflects this kind of common milieu again as to that geometry is motion. So since the last talk, what I've done is I've finished sort of reading this biography of Tarski. So Feferman's book that is a biography of Tarski is about Alfred Tarski. And so imagine if today's 2024, that about 100 years ago and 100 plus years ago, there was a time and a place, and it was Europe, and it was Poland. And Poland became a center of the study of formal logic. So after Augustus de Morgan and George Boole, then that Boole's great symbolic logic was kind of carried forward as an algebraization to make an algebra of something and put it in symbols for their algebraic manipulation and making derivations. That Poland became for a while a center in the development of methods of abstract and symbolic logic. And so the figures people will be familiar with are Lukasiewicz, and then there was Lesniewski and Tarski. So Tarski was born Teitelbaum, was a man, and he's quite a character. And he has a lot going on with regards to then that he came up in his academic career as an individual, and he was much of what you might call a bon vivant, or for his joie de vivre, if that's a generous way of saying that he was pretty loose, and then he was a lifelong addict, functional, I guess you might say, but this was just kind of his part of his story that the Fefermans relayed. Where Solomon Feferman was a student of Tarski. So Tarski was an academic, and it really was that he saw that as for its value, the ivory tower and all this kind of stuff, which reflects our canon and the culture of academia, and then that he was sort of a self-aggrandizing man, and very much so was interested in the priority of things and being in the midst of things. So he then met very interesting and influential people, and he was very continental and also a traveled man, and he and his wife Maria had a lot of events in their life. And so at the same time, Tarski was very much just an individualist who though really wanted to have a coterie of people around him. So some touchstones of Tarski's colleagues include his involvement with the Vienna Circle. So the Vienna Circle is, speaking of Boole, and that there's comps, and then scientisms, and then logicisms and positivisms, that the teleological aspects, though largely abandoned after Comte, and the notions that science and scientism was really to be our means of establishing the truth of things, or that which can be said to be true. That the Vienna Circle was kind of in the sphere of Carnap. And so Carnap was then sort of the touchstone of the notions of these existentialism and some other things that come out of the Vienna Circle, which is basically an influential set of colleagues and the disseminations of their opinions, and what with regards to that coming up as then being considered the right way to do things, and the very clinical academically in these things, these ways. So then also Tarski met Quine. Now Quine was Willem van Ormond Quine, who went by Van sometimes as his name. That was his name, not so much a traditional way of writing somebody who's from somewhere or something like that, Van. And in this manner, Tarski, in the time before World War II, had it so that he escaped Poland before the pogroms and these other aspects of the conflicts of the 20th century and World War II and all these kinds of things. And it's sad that then much of his extended family died in World War II. Tarski escaped fundamentally to America, and then his wife and children later escaped and joined him after World War II, and that this was kind of just speaking to the conflicts of the time and the tragedies of the time, these kinds of things. So Tarski made it to America, and then to Berkeley, California. And what happened is that he had written a few papers that kind of established in this sense of logicism and positivism which I call kind of weak logicism and weak positivism, because I posit a stronger logicism, a stronger positivism, with this whole metaphysic, that the metaphysics must come back into the theory somehow, and that this is a matter of objective philosophy that anybody can make for themselves, and that it's very much so that the empirical is not a replacement for the dogmatic of the monism, and so the logicism and positivism as basically is just like, this is refined empiricism, is this weaker sort of form. So the papers in terms of the Tarski truth, as we discussed about, and that gets into what are some ways to look at readings of what he has and what he said with regards to the way it is, and whether it's just really a correspondence theory or a pragmatist theory or a coherent theory of what is truth in terms of, well, these days the fallibilist and infallibilist of the theories, when they ever have vis-a-vis proofs, they're refutations, and the modality of things for the monotonicity of logical theories, that being the property that it's just more true, it doesn't kind of, just end at the edges or something like that, and that is true under various contingencies, that the modeling of contingencies is our exercise of abstract theory, and that while there may not be multiple worlds of all the parallel universes that can never interact, but it is yet as well that this perfectly suitable theory of the abstract, while at the same time there's a reality, and there's a theory of that as well, and it is concrete. So Tarski had written some influential papers, largely courtesy his colleagues in these schools, and then it so resulted that he, with his influences, also so related to the center of logic that remained in this European context, that it sort of resulted then that he grew a program, and that he was constantly aggrandizing this sort of logicist positivist program in the 20th century, especially after the war in the 50s and 60s. And so he drew a great number of colleagues and his students and to Berkeley. And so when we talk about the Berkeley School, then that's like the Berkeley School of Logic, and then it largely reflects what you'd say would be the American logic of the 20th century. And so it doesn't necessarily have to just be the classical quasi-modal logic. That's also an offshoot of logicism and positivism, but it's really here considered that as the quasi-modal, that it's easily wrong in the sense that it's not modal, it's quasi-modal, and this kind of thing. It's a finite fragment of the things. But then there was also a lot of involvement in the Boolean, and so when you say the Boolean, it means at least two things. And so it means one or the other. And then here, in terms of logic, one sense is the quasi-modal logic in terms of truth values, the semantics of truth values. And then also as with regards to the completions of things, and this constancy and consistency and diversity and variety, essentially reflecting for inverses, the inner and outer products and stipulations and inference and the rules of inference, the laws of inference, and all those kinds of things. Then if there's one reason that this school became especially influential is because at the same time the logic of computing machinery became a thing, and its formalization became a thing. And so Tarski wrote he was lucky to be in a time and a place where he could write some very fundamental logics for the logics of relations, is what we talk about, type theory and category theory, and also for that being in terms of just numbers themselves, the arithmetizations and algebraizations, if not quite the geometrizations, that was able to be used to formalize and to reflect in the literature all such these manners of the apparatus of the computing machinery, and as what became why then the Berkeley School became so relevant vis-a-vis the detachment from kind of what was right before that. So there's two kinds of things to reflect upon that are kind of right before that. The 20s and 30s. And one is that there's Vitali and Hausdorff. So Vitali and Hausdorff are very much involved with the axiomatic set theory and descriptive set theory with regards to the measurability of things and the measure problem. That the measure problem is like, how can we take an area and divide it down to points and add them back up? And Vitali basically introduced his construction where he says, I've taken a line segment and split it up into bits and I put them back together and now it's twice as many. So this is, then the theory said, what we're going to do is just call that non-measurable. Some sets are non-measurable. Even though they just are what they are, they add back up. It's like, according to our current way we're going, that we build it this other way, and so, but at the same time, it's a way to look at that. I see you've invented a doubling space or doubling measure by the very act of having so divided something like that. It results that making a space for each one to individuate each element of this continuum, that it's given each one its own discernible identity. From what were points in a line to now they are points pointed at on a line. So Vitali and then Hausdorff. Hausdorff was a great geometer, and Hausdorff is basically in this time and place when it went from being geometry is mathematics to algebra is mathematics. That it's right there, kind of in the middle of algebraic geometry, where it goes from being algebraic geometry to algebraic geometry. So Vitali and Hausdorff are one key thing to say that this is what we'd revisit and pull into the future. And then there's Lukasiewicz, and so Lukasiewicz is got, well, there's truth values, and when you don't know or don't care or it's null or void or empty, that there's either true or false. And in these tables, if it's something other than true or false, you can't just put true or false because either one of those wouldn't be right. And somebody will come along later, and that would be a hazard because it's lost. It's got not enough information to solve the problem. As for any other kind of problem, when it's posed a problem and they're given some possible results and it says there's not enough information to adequately, in terms of adequality, to adequately pick one of these results. So that's just to say that Tarski is part of the time, and so he's a touchstone of the times and a great man. And so many people, or at least the Fefermans, have really much a glowing sort of opinion of Tarski as one of the greater logicians who was able to, via his prodigious output and wide influences and his constant aggrandizing of his circle and his influences, to kind of reflect these times. So Feferman's book on Tarski was a pretty good reading, and it kind of reminded me of Einstein's Out of My Later Years, but not the same. So when Einstein wrote Out of My Later Years, it's just kind of like, well, in the beginning and end, he describes things about his affairs in the world, but in the middle, it's just, this is the theory of relativity. whereas Feferman's biography of Tarski is largely biographical and expresses kind of like the realm and the surrounds, but it does have a bunch of different interludes within it that describe basically these fundamental things ongoing in terms of essentially reflecting eventually on model theory. There are model theory and proof theory is for us structuralists and constructivists, that we can still have our intuitionists that come in to make what is model theory for all things from the foundations, what for logic, and thusly the universe of logical objects, and then mathematics, and those objects that there's addressed how to deal with that algebraically and geometrically. So one of the really interesting things that, and when people would first hear of Tarski, they hear about Banach and Tarski, the equi-decomposability of a sphere into two identical spheres. And so this harkens immediately to Vitali and splitting the line and resulting in a doubling space. And indeed, then, it was after Vitali that Hausdorff first made this Banach-Tarski equi-decomposability of sphere into a ball into two. And so this is said to sometimes called Banach-Tarski paradox, because you can't get one into two parts that each equal the original. That's not the measure problem. It's not a solution to the measure problem. But really, it kind of just reflects that in the one dimension, there's this doubling space and doubling measure, and in the three dimensions, there's this doubling space and doubling measure. Then in two dimensions, in the planar, is really where there's lots of dynamics about that. Because in the 1 and 3, it's just kind of interesting that this notions for the quasi-invariant of the measure theory, that the measure problem should so result that, according to measure theory, that it's invariant, and so when we describe it either this way, these modern ways, like Bergelson and Oproka. These are two modern researchers in this field with many papers in quasi-invariant measure theory. That here it's just the notions of the doubling spaces and the halving spaces with respect to Borel versus combinatorics and the almost all and almost none, and they meet in the middle of the square counterspace with 1/2 apiece. That these are the kinds of things that go on. So one way to look at it, that then for the relational algebras and cylindrical algebras is that those are algebraizations. And so the Banach-Tarski way of describing this equi-decomposability of a sphere is, on the one hand, it's an algebraic approach to things, and the other hand is that after Vitali, that Hausdorff already had made a geometric approach to these things. The geometric proof of the Banach-Tarski paradox, or equi-decomposability, is different than Michelski and company's usual these days is presented proof of the Banach-Tarski paradox, algebraics. One is after an algebraization of the space of words. The other is a geometrization of the space of points. Two different ways that meet in the middle, which unfortunately, though, are not really brought back together. That's what needs to happen is that both these results need to be equity-interpretable, the algebraization and the geometrization, in terms of each other. So this is one of these things that's an issue in foundations that is kind of buried under a lot of the results today that are hard to keep in track, because when trying to learn the field today, it sort of involves trying to learn the field of how it arrived, and that the geometrization needs to be more fully explored. Then another kind of issue in the great advent of the formal logic and the voluminous ballooning of the output of academia since the 1950s and 1960s and the 1970s and to today, is that a lot of things then were just independently invented because it was at times like a lot of new things were coming up. And so when we think about the relational algebra, then the other way we'd hear about this is the relational algebra of the relational database and the relations of items, the tuples, according to what is a relation, according to usually these days what's called relational algebra with rows and nulls, because introducing nulls and introducing rows is a notion of otherwise these tables are like so. So E.F. Codd's relational algebra is just generally considered an entirely independently discovered and independently developed, theory that Tarski was, a great logician, but a lot of this stuff was just sitting around for the taking. And it's good that we kind of have this central nucleus of these sorts of developments to help relate a lot of these things, and then it kind of has a common thread out into the algebraization of the Berkeley school. Then that besides that, there are things like the quasi-modal and vis-a-vis what's Boolean or Boolean, and these kinds of things still need to get sorted out. Then this entire also other notion of the geometrization for the measure problem needs to get sorted out because it's just as relevant and in some sense more so than otherwise the space of words and the space of numbers. Logic, a universe of objects, logic. So that's that just kind of helps reflect what was going on with that. So I enjoyed reading that book though, and I learned some things about it, and it helped me understand some more of the placement of things and what people see as the priority things, and how things are arrived at, and where there's entirely alternative developments, and where there's independence of the discoveries of these things, and that there's quite all these different things. Alfred Tarski, Life and Logic. So, this is a portrait painted by one of his bon vivant friends, or drawn by one of his bon vivant friends when Tarski was a young man. So then otherwise, what I've been reading is, I've been kind of getting through is Frege. So Frege, as we talked about, mentioned up a little bit last time, is also right after the time of Boole. And so symbolic logic. So what Frege introduces here is that he started the development of a lot of what he calls the concept script. So a concept script is also in this world of truth tables and inference, making for the assignment of quantities and predicates and relations, and the establishment of the syllogism for assertions and as what are stipulations. What's so result that a concept script is basically an approach to then mechanically, according to a set of rules based upon relations to their inferences, to be able to draw the conditions together and result that after working it out, then it provides a means to mechanically produce results of inference that according to it, if it's kind of defined correctly and not garbage going input, then it's defined correctly when well defined, and that the behavior is defined and not garbage output. So the concept script of the begriff of Frege then is quite an approach to these things. And so if we look back on that, this gets into NAND and NOR for and or, the usual conjunctive and disjunctive, and all these kinds of things that go into usually as about the law of excluded middle, or principle of excluded middle, or tertium non datar, and where that's either a class of relations that are closed thusly, or if it's that's the universe of things, tertium non datar, that's one of the classical ideas, when if it's not dual monism, then it's just kind of tertium non datur. That Frege then had a bunch of these different developments, and so Frege is a man of his time and place, and the concept script is a pretty good idea. And so then we look at like Scheffer, and as we fast forward today, we get into like Kripke and Gensen. And so then that might get into like Herbrand or something like that in terms of modern day approaches to these things. And then this whole quasi-modal logic is an approach to these things with its caveats, with its weaknesses. And that these various different sorts of approaches to the truth tables, the tableau, are all these different kinds of things. So Frege, as I've been reading it, it's basically a bunch of essays about the development of the concept script and what that means, that it's a means of formalized inference as a matter of diagram and their ability to kind of pull these things together like so. So Frege had already had like this great thing going on. Before Principia Mathematica and Russell's then retro-thesis was like, well, we're going to have an infinity, but it's closed. It's like, well, you just told us that infinity would always kind of force us open. He's like, well, this is just the one that's closed. The retro-thesis is one of these axioms of the restriction of comprehension. So it's taken the entire universe of logical objects and said, we're just going to have these ones like so. And they work one-dimensionally, one direction, one way, closed. And then to build it down from that and build it down from that, so it results something we can just say, here's a linear narrative, anybody can follow it, these kinds of things. That it really kind of gets into that, and for the completion, because the completions then are this other great thing of the completion of a journey or a path out through a space to another end in the space. About the means in the middle and the ends, here moment and motion, geometry is motion. That in these general ideas, it's that we're just thinking in words and they kind of come together and they kind of just march on out. It's an ant, it marches out, it goes and reaches destination, or close enough. So Frege had already written his laws to help show that the operations of arithmetic are closed, and then after that, and then Russell and what became the Vienna Circle and logical positivism and these kinds of schools and currents of the time, and empiricism's close enough. Sort of arrive at that this is kind of the thing. So I've been reading this. It's kind of interesting because he gets into a lot of the necessary stuff that would go into making the objects of the discourse that today we just call type inference, or in the world of programming languages. Because there's something again to be said about logic and logic in the large, and the logic of computer programs is something along the lines of that today we have computer chips and it runs in gigahertz, which is kilo for thousands, mega for millions, giga for billions of ticks per second. And that the storage, the storage or the amount of memory isn't just, in the internal registers of the chip. Each one of the registers has got a word width. It's about 32 or 64 bits. There's maybe 8 or 10 of them, and out in some banks that make about 15 or 30 of them, and some of those are kind of parallel, split up to be run with the same either way. And it gets out in the L1 cache, and then it gets out in the L2 cache, and it gets out in the L3 cache. Each one of those about an order of magnitude bigger and order of magnitude slower. This gets up in the megabytes, where a byte is 8 bits, and into the kibibits and the megabits and the gigabits, usually where giga means billion, but for kilo there's 1,000, and kibi means 1,024 because 1,024 is a natural power too, whereas we think of our usual systems of units in terms of the decimal, orders of decimal magnitude. So then out into that, it gets into like, well, now we have random access memory in the usual models of these computers of computation. For example, your smartphone has got about, megabytes, if not gigabytes of random access memory. It's really rather remarkable because even just 20 or 30 years ago, like a megabyte of RAM was $100. And the idea of having more than like 3 or 4 of those in one computer was pretty outrageous. Whereas something like a supercomputer would have a superscalar architecture, and it was like, well, it's basically we have this Cray supercomputer, and it's got a word width that's about a couple thousand, a couple 100,000, past 64,000, out a ways, It's resulted in embarrassment of computing resources, just beyond any idea that there would be not exponential growth in the amount of computing resources, according to this industry. And so this little formal apparatus of logic now is looking at like billions of rows per second. It's really rather remarkable, and in the fact that it's not like the world has one of these, but it's just ubiquitous, has really changed a lot of these things. So the completion and then getting into the entire theory of the things is that while that's still also grand, it's essentially yet finite. Bounded, but the bounds are very large vis-a-vis the unbounded, the infinite. Here, as we've been talking about the practical and potential and effective and actual infinity and these kinds of things. So Frege anticipated a lot of the things that go into formalization of the completions of arithmetic and algebra, and when they come together, and then that it was just kind of left open by Russell's retro-thesis that we're going to restrict comprehension in this manner, make it a theory, and then we're going to call that our foundation. It's not necessary for the universal mathematical objects. Theory doesn't have a universe in it. It's one of these immediate things. It was like, well, what's our theory of our universe? It's like, well, let's just keep things centralized and what. So it doesn't really work out that it's really the foundation until it does have these kinds of things. And this again is where the metaphysic comes back in. So I'm making this stronger scientism, stronger positivism, stronger logicism to arrive at then as the empirical gets fulfilled, the empirical theory gets fulfilled by the fundamental theories, that it's not falsely verified, the verum and the certum of the things, the truth, the verum, and the certification, the certum of the things, the empirical and the real of the fundamental of the theory. So that gets into why, it's so that Frege's arguments classically will stand up quite well. And he gets into the signs of things, the semiotics, how do we assign signs and symbology to the thing, then vis-a-vis the qualitative, the quantitative. Here, for example, is a paper from Frege, and I haven't read it yet. It says, logical defects in mathematics. There is little cause for satisfaction with the state in which mathematics finds itself at present, if you have regard not to the outside, to the amount of it, but to the degree of perfection and clarity within. In this respect, it leaves almost everything to be desired if you compare it with the ideal you may reasonably propose for this discipline. And when you consider that by its very nature it ought to be better fitted to approach this ideal than is any other discipline. So that's the usual Platonist notion. It's like, somehow it's perfect, We want to approach this. We want to attain to this. We want to ascertain it. We want to attain to it. And close is not enough. If you ask what constitutes the value of mathematical knowledge, the answer must be not so much what is known as how it is known, not so much its subject matter as the degree to which is intellectually perspicuous and affords insight into its logical interrelations. And then he discusses what's going on in the formalism of analysis and Riemann, as we've been discussing here with regards to a lot of the talk in descriptive differential dynamics, which I'm pretty happy about, and there's plenty in that. And he writes the sign. He says if of an integral, and in Leibniz's usual notation, the integral from a to b of f of x dx. And so I haven't read this article yet, but it just helps reflect that there's issues in mathematics and logic, and the way it is today still has some room for renovation. And largely, it's not anything really fundamentally fabricated. It's revitalizing the aspects of the geometrization, and then the aspects of the metaphysic that come up into the algebra of words and signs. That is how it's so built for type theory and category theory, to arrive at these notions of these the implicits in quantity, and the classical, the standard, and the linear, super classical, the super standard, and the curvilinear, but the virial, the spiral, and what results, the extraordinary, a universe of logical mathematical objects. So there's a great deal of talk about variables in the mathematical literature. Sometimes you hear about something like theories like, well, we just kind of like to write this so we get variables out of it. And it's like, well, on the one hand, that would be a great simplification. On the other hand, it would be, in a sense, an oversimplification. And you'd be leaving out all this stuff that goes into quantification of variables, and also leaving out all this stuff that goes in building up their derivations when close enough is a bit too much, in this sense that the derivations are related and they're consequent each other, and it's an improper assignment to otherwise forget and result with not enough information to come up with these things. So then this also reminds me of earlier in the reading of the Imre Lakatos in Proofs and Refutations, because he identifies a couple different cases, and then this introduces the notion of the fallibility and infallibility of our empirical justifications of the logicist positivist program. And the fact that it is so that there's sometimes that these things, whether it's theories of physics or theories of mathematics, that need to be fundamentally revisited because either their completions were circular in their definitions, like Russell's retro-thesis, now I'm done, this kind of stuff, vis-a-vis they didn't really approach the ultimate circularity of like, is it a point or is it a space? Well, it's the way it is. These kinds of things. And so the determinate number, y, is defined as a number, which is at the outset indeterminate, which depending on the problem in which it occurs can assume indefinitely many values. So the variation presumably consists in the fact that the number, which at the outset is indeterminate, gradually works its way through to becoming determinate. All the same, it is remarkable that the number y, which has become determinate in this way, is still a variable and consume indefinitely many values. Which is the problem in which y occurs, and which the problem in which x occurs? So here we get into these notions of quantities, and I'm still kind of working on one of my idea fix called the identity dimension, and helping explain how that helps relate constants and variables, the parametric, and how that results as completions, both inward and outward, of these sorts of forms. Whoever holds Euclidean geometry to be true will ascribe a sense to each of its theorems. In Euclidean geometry, certain truths have traditionally been accorded the status of axioms. No thought that is held to be false can be accepted as an axiom, for an axiom is a truth. It's a stipulation. The idea that our theories that are stood up today, like Zermelo-Fraenkel set theory and Euclidean geometry, have true axioms, has that each of the axioms have been very carefully considered with regards to their independence to other axioms, and their validity usually is what's with regards to them being true. That they are not counter to the intuition, or do not introduce or make consequent the invalid, unsound, these kinds of things. That said, the idea of the axiomless natural deduction is that that's arrived at from the metaphysic, the universe of logical objects at all, via just there being an inverse and these kinds of things, that truth is not an axiom. And axioms are not true. Axioms are stipulations, they're suppositions, they are non-logical in the sense of what with regards to a theory and its meta-theory, whether those are one and the same. That an axiom or a principle ends up being that it's in a theory, an axiom is rulal. And in a theory, the independence and non-contradiction of axioms is a primary feature determining whether that theory is coherent, and that also that its formulas or sentences, statements within it are unambiguously either true or false, or don't know, or don't care. Just saying so that these are the kinds of things. In a parenthetical reference, Frege says, truths can be inferred in accordance with the logical laws of inference. So we kind of have this notion of truth, or what is wall, and in terms of, emptied or hollow to full, whole to full, and then we have moment in motion, and this kind of thing. And then it kind of reflects on what is Euclidean geometry and what is non-Euclidean geometry, or super-Euclidean geometry. The only basic idea that the parallel postulate of geometry has that it's the only one let out, and with the idea of the Riemannian or Lukasiewicz or the geometry. I'm wearing a necktie today, and it's a print from a mathematician and a designer and an artist named Mauritius Escher, M.C. Escher. And so he was very well known for his great tilings and tessellations, and then also the ability to use projective and perspective geometry, which we usually point to Mercator and all these different ways to project one surface into another surface. It results in conformal mapping, kind of like that one picture in the book of the Vitruvian man with an affine transformation or a conformal mapping applied to it that results that it has its kind of background. That a couple people I wanted to mention today were M.C. Escher and Mobius. And that Mobius, or Moebius, M-O-E-B-I-U-S, Mobius, or the M-O umlaut, where I tend to transliterate everything into Latin script, and there's no accents in it, and I understand that there's a certain loss of information in that, but then the transliteration usually involves that it's understood that the accents as necessary to indicate unambiguity will be reflected in a transliteration. So anyways, Escher has a lot going on with the graphical depiction of Euclidean and non-Euclidean geometries in their projection, in their perspective, because there's no such thing as a non-Euclidean geometry. There are transforms with regards to projections in perspective that would sort of result it, but the only reason they exist is coming back to Euclidean geometry. So it's just something to be clear that when we say something like anti-de Sitter space or Riemannian geometry or Lukasiewicz and these kinds of things, that in terms of the geometry, that those are of a space that still is this Euclidean space. The algebra of words is an entirely not necessarily continuous thing at all. It doesn't necessarily have this continuous topology among it. It has can have a topology of words, and it can immediately start getting into the vague fugue of these things. You know, it's again back to this, the difference between the algebra of words and the geometry of spaces, and how those are still the same universe of objects together with regards that phenomenologically and symbolically and one at a time we can start, classically. The classical is this way, vis-a-vis that our classical theory of mathematics already has, it's got geometry already in it and this kind of thing. So this is just something to relay its relevance and importance as we get into this thing. So and then here's another work that I haven't read yet. That is The Elements of Geometry and the Five Groups of Axioms. Frigi's Notes on Hilbert's Grundlagen der Geometrie. So Hilbert, as we came to the end of the 19th century and Vienna Circle in the 20th century, then came up with an axiomatic geometry to complement Euclid's, and then also, and as well, that he added a postulate of continuity, because making a world of point sets that together comprise lines then needed to have something that helped to establish that, yes, Euclid's geometry had always kind of been missing this postulate of continuity, and that line drawing in Euclid's geometry is left undefined. Kind of like in moment and motion, when rest and motion have changes undefined, it's just to reflect that the classical constructions of Euclid's methods in geometry do not include actually drawing a line at all. It says 2 points establish a line, but how you make it is your own mark. It's your own opus, your own fate accompli. That is how it is. And so then actually getting to defining this in terms of our continuity is reasonable, necessary, and relevant for our foundations. It's the way it is and how it should be. That it's not without its vagary and ambiguity that needs to be cleared up. And it's exactly so that it does. So I'll look to this a little bit more about trying to understand what's going on for geometry and the revitalization of measure theory, and making that there's always an account of how geometry and algebra of words meet in the middle for Banach-Tarski, and then especially kind of as it was brought up in the space inversion bit, and then as for how the polydimensional and pandimensional make for the sides of points in a line, on a plane, in a sphere. That these are the things that get into the needful for explaining continuum mechanics and the mechanics of the continuous and discrete and the quantum mechanics, and helping explain for the ultraviolet catastrophe and the great success of electron physics, and coming back for the notions of decay and the continuous again, this ultraviolet catastrophe, and the recontinuification of physics, the theory. It's all one theory. This arrives naturally from metaphysics and axiomless natural deduction. Frege also introduces the notions of an idea is like a Plato's ideal. So it's like an idea is like a circle. It's well defined. It's the points at a constant radius from a point in a plane. And then he introduces the notion of his thoughts. Is like, well, thoughts are just contingent. So thoughts are basically his whatever is any kind of abstract thing at all. But then he kind of starts to build his notion that of thoughts as we call them statements. He says, I call something a quasi-sentence if it has the grammatical form of a sentence and yet is not an expression of a thought, though it may be part of a sentence and that does express a thought in this part of the sentence proper. So he seems to have this notion at once that thoughts are well-defined and well-formed formulas and in sentences, and also that they are not. So when reading Frege, there's much to be said that his notion of the formula and the sentence and the statement and the depiction and the symbol is matters of ideas, which he sees as basically his idea thought distinction is that ideas are true and thoughts are any such thing. Sense and meaning, or the Bedeutung. Question arises about the unsaturated part of thought. Brief survey of my logical doctrines, so these would be his principles, the thought. When I use the word sentence in what follows, I do not mean a sentence that serves to express a wish, a command, or a question, but one that serves to make an assertion. An assertion is generally like, this must be true. So if it's not true, then it just doesn't exist. The idea of assertion in a programming language is kind of like, I either evaluate to true or I end. The only defined behavior I have is to terminate the entire program. It's an assertion. Although a sentence can be perceived by the senses, we use it to communicate a content that cannot be perceived by the senses. Here we have introduced our reflections on our object sense, our number sense, our word sense, our time sense, in the sense of the continuum, helping make it so that there does exist this stuff according to the phenomenological sense. So that's kind of what we'll have gotten into today. And then there was some more reading. It was Badu, if I may correct the pronunciation of this, about the ideas these days in terms of the phenomenological and sense and meaning, this kind of thing. This is just the Penguin Classics, early Greek philosophy. And so, then Heidegger on metaphysics. But then this is where we'd find for the super-classical and the extraordinary and the revitalization and revitalization of the theory with the metaphysic for the logicism and positivism, the stronger logicism and stronger positivism and a super-scientism, to reflect on the moderns, the empiricists and pragmatists that came up as after the symbolic, what reflects on the ancient in the canon, what we have as our didactic rhetoric that is logical and reflects our aspects of theory, meta-theory, and the metaphysic, a theory, and then to the prehistoricals. These are the notions that in the antediluvian or before the flood, that there are these same concepts, the silver thread, would arrive at this from the Vedics, or how these things are, for examples of the continuum as a spiral space-filling curve, or the geometrization and the algebraization as complementary concepts, and that have to go together. So yeah, then about Escher and Mobius, they're commonly introduced as the two great enrichments in terms of attachments of the theory of these things to their pictorial representations, and their manifestations basically with the Mobius strip, which is you take a piece of paper and give it a half twist and you tape it back together, and then you put the pencil down and you draw a line down the strip, and by the time it reaches the point you started at, when you turn the strip over, you see that both sides have a mark. And so that just gets into this notion of this subtle alternation that arrives at a fuller complement of the space. Well, I shall so hope you have a nice day today, and I hope things are well with you and yours. I'll think here that the logic sort of notion for moment in motion is sort of established, and it's extraordinary, and it includes the perspective of modern logic and classical logic, and it's pretty particular in its expectations for what is truth, and then what is matters of consistent derivation, and that there is more than one kind of inference. Inference is pan-dimensional and polydimensional. It's true. So these kinds of things. Moment in motion. Geometry is motion. Or words.